Up until this point, we have not dealt with large amounts of information, and we have not needed to store this information for retrieval. As the amount of information increases, we need to design circuits that will help us abstract the increased information so that we can successfully design a larger system. There are primarily two types of circuits that we can use to store and retrieve large amounts of information: read-only memory, or ROMs, and random access memory, or RAMs. Before I describe how to design these storage devices, I want to explain the principles that we will use through an analogy. Suppose that you want to store information about all of the homes in a large city and which rooms have televisions in them. For the sake of simplicity, we will assume that every house has the same number of rooms. We will need to know where to find the houses, and then we can identify which rooms have televisions. Just like the way we use numbers and streets to address a house, we could encode the information about where to find the house as a binary address. In this example, we have 4 houses, so we need only 2 bits to encode the location of each house. Then, we can encode which rooms have television by assigning a 1 or a 0 for each room. So our city can be described by a set of address bits and a set of data bits. If we increase the number of houses, we need to increase the number of addresses, and each additional address bit doubles the number of addresses that we can encode. If we increase the number of rooms in each house, we will need to add 1 bit for each room. Notice that adding 1 data bit does not double the number of rooms that we can describe, because each data bit describes the data. Address bits encode information about the location, but data bits are the information. Similarly, when we design ROMs and RAMs, we use 2 different types of bits. First, we encode where to find specific information within a set of address bits. These addresses indicate words that all contain the same number of bits. These data bits are information, much like whether each room in the house is a television. The overall storage capacity of a ROM or RAM can be calculated by multiplying the number of addresses by the number of bits stored at each address. If we want to double the number of addresses in a storage device, we simply need to add 1 additional address bit. In contrast, if we want to double the number of bits per word, we need to double the number of bits stored at each address. When we include a storage device in a circuit, we will typically indicate the dimensions of the storage device, where the first number reflects the number of addresses, and the second number reflects the number of data bits per word. Although ROMs and RAMs are both information storage devices that store information at addresses in words of a fixed length, they serve different purposes in a computer. ROMs are devices that are combinational circuits that are programmed once, ideally, and will never lose their information, even more ideally, even when they lose power. In contrast, RAMs are volatile and lose information when they lose power, but they can be easily rewritten because they are based on sequential circuits. In future lectures, you will learn about the differences and how we implement these different storage devices. But these devices are all developed around the same concept of addressing information with a set of bits and storing data with fixed length words.